Assalamualaikum everyone, welcome back to our channel. In today's video, we are going to do some calculations on how to get our final concentrations based on the calibration curve and how to calculate the percentage of degradations. First, let's understand the essence of calibrations. Calibrations is the process of adjusting an instrument to ensure its accuracy and reliability. Calibrations is crucial because instruments may deviate from ideal measurements over time. External factors such as temperature, humidity can impact their accuracy. A calibration curve acts as our compass, guiding us back to an accurate reading. It allows us to correct for any variations and maintain the reliability of our measurement. Next, let's generate this calibration curve. First, we must find the concentration for 5 RBB solutions and the makeup volume for each of them is 10 ml. To find the concentration, we just divide the sample volume by the makeup volume and multiply it by the stock solution's concentrations. Then we just insert the absorbance value that came from the experiments. After that, we generate the graph by taking the value of absorbance and the concentrations. The graph that was produced is linear. Now that we have our calibration curve plotted, we can measure our final concentrations using the linear formula y equals to mx plus b. Y represents the absorbance and x is the concentrations. The slope m represents the molar absorptivity, and lastly the p interprets the planned absorbance, which is the baseline absorbance when there's zero concentrations. From this equation, we can conclude the molar absorptivity is 7.77.
So, for the calculation of the final concentration, we use the formula of x equals to y minus c over m, where x is the final concentration, y is the absorbance, and cm is the constant that can be found in the calibration curve graph. So, for example, if you want to calculate 1 gram of sample with 1.960 absorbance, so we just input the values inside the formula that I mentioned, and we get the final concentration, which is 0.2504. Same with 2 gram of sample with 1.817 absorbance and 3 gram of sample with 2.016 absorbance. For 2 grams of sample, the final concentration is 0.2320, and for 3 grams of sample, the final concentration is 0.2576.
Hi, my name is Nurul Izzati Yusri, and I will continue for Nazahat's part. As you can see, Nazahat's find the Cx, which is final concentration. So, my part is I will talk about the percent of degradation, or we call as percentage of removal rate. So, the formula for percentage of degradation is C naught minus Cx over C naught times 100. So, we need to find the percentage of degradation for 1 gram, 2 gram, and 3 gram. We begin with 1 gram first. For your information, C naught is initial concentration and Cx is final concentration. So the percentage for degradation is negative 0.15%. Continue with calculated percentage of degradation for 2 gram. It is the same way to find the percentage of degradation for 1 gram. After we put the value for 2 gram into the formula, we found that percentage of degradation is 7.21%. And lastly, for 3 gram, we do the same method for 1 gram and 2 gram. So, we get the percentage of degradation is negative 3.03%.